Okay, we're going to talk today about multiplying a polynomial by a monomial. And this is going to look a lot like the distributive property. So let's review what the distributive property says. If I have A times the quantity B plus C, what will I get? Should get AB plus AC. If I have A times the quantity B minus C, what will I get? I should get AB minus AC. Notice that the sign inside the parentheses stays the same once I distribute. So we're going to take a monomial. Let's say that monomial is negative 3x squared. And I'm going to multiply it by a giant polynomial. Well, not all of them are giant. This one happens to be a trinomial. It's 7x squared minus x plus 4. So, using the distributive property, this whole thing, negative 3x squared, is going to be distributed to each piece. Okay? So, when I multiply negative 3x squared times 7x squared, negative 3 times 7 is negative 21. X squared times x squared. I add those exponents if I remember my exponent rules. So I should get x to the 4th. Then negative 3x squared times negative x. Negative times a negative is a positive. Remember, there's that understood 1 here. 3 times 1 is 3. X squared times x is x cubed. Then I multiply that negative 3x squared times positive 4. A negative times a positive is a negative. 3 times 4 is 12. And then that x squared comes along for the ride. So go ahead and try this next one on your own. I will have 5a squared as my monomial. And my trinomial will be negative 4a squared plus 2a minus 7. When I distribute to all of the terms of my polynomial, 5 times negative 4 is negative 20. A squared times a squared is a to the 4th. 5a squared times 2a should give me plus 10a cubed minus 35a squared. Once I know how to do this, I can also use it to simplify expressions. So, for example, maybe I have 2p as my monomial, and I'm multiplying it by negative 4p squared plus 5p. And then, in addition, because we know how to add and subtract polynomials, I have this negative 5, which negative 5 is a monomial, and it's being multiplied by 2p squared plus 20. So, let's break it into parts. I'm going to distribute this 2p to these two things first. 2p times negative 4p squared should give me negative 8p cubed. 2p times 5p should give me plus 10p squared. And then I need to distribute this piece. Negative 5 times negative 2p squared, and then times the 20. Negative 5 times 2p squared would give me negative 10p squared. Negative 5 times 20 would be minus 100. Now you will notice that I have two p squared terms that I would like to probably combine like terms with. So I have a plus 10p squared and a minus 10p squared. What's going to happen to those? Right, they're going to cancel out. So I'll have negative 8p cubed minus 100. Try this next one on your own. My first monomial is 3 multiplied by the polynomial 5x squared plus 2x, minus 4, plus my second monomial is going to be negative x times the polynomial 7x squared plus 2x minus 3. When I distribute that 3 to all of my pieces, this will give me 15x squared plus 6x minus 12. When I distribute my minus x or negative x to all of the pieces, that will give me a minus 7x squared, cubed. Let me erase that so it looks more like what I want. Minus 7x cubed minus 2x squared, and then plus 3x, because a negative times a negative is a positive. Now, if you like to do adding polynomials by lining them up, that's fine. This one has a 0x cubed term, plus 15x squared, plus 6x, minus 12. Remember, I have to line it up by the variable with the correct exponent. So this is a minus 7x cubed, minus 2x squared, plus 3x, plus 0. When I add those, I'm going to get a negative 7x cubed. 15 minus 2 is a plus 13x squared. 3 plus 6 would give me a plus 9x. And then this is a minus 12. So that's my answer. The last thing we're going to talk about today is equations with polynomials on both sides. Dun dun dun. We've done equations with variables on both sides. So this should be slightly familiar. It is going to be a little long. So let's say I have 2a times 5a minus 2 plus 3a times 2a plus 6 plus 8. And that is equal to my other side, which is a times 4a plus 1 plus 2a times 6a minus 4 plus 50. So lots to do. The first thing we need to distribute to my correct things. I'll use orange for this side. So on this side, 2a times 5a is 10a squared. 2a times negative 2 would be minus 4a. Plus 3a times 2a would give me 6a squared. 3a times 6 would be plus 18a. And then don't forget to bring down that plus 8. And that is equal to a times 4a would give me 4a squared. A times 1 is just that plus a. 2a times 6a, 12a squared. 2a times negative 4, minus 8a. And don't forget to bring down the plus 50. Now, if I can, I'm going to combine like terms on each side. So over here, I have a negative 10a and a plus 6a, which will give me 16a squared. I also have a minus 4a and a plus 18a. A positive 18 and a minus 4 will give me a positive 14a. And I have nothing to combine this plus 8 with, so I just bring it down. On this side, I have a 4a squared and a plus 12a squared. When I add those together, I will get 16a squared. I also have a plus a and a minus 8a. Positive 1a minus 8a will give me minus 7a. And I don't have anything to combine the 50 with, so I just bring it down. Then, I would like to go ahead and solve for a if I can. And I know there's an a squared here, but watch what's going to happen. I'm going to subtract 16a off of this side to move it over here, which means I'm going to subtract 16a squared over here. Oh, look at that. They cancel on both sides. What? So I have 14a plus 8 equals minus 7a plus 50. We know how to solve equations like this. You did it on your last test. So I can add 7a to both sides, because remember I want all my variables on one side. So over here I have 21a plus 8 equals 50. I may need to bring this over here so I can actually work. I subtract 8 off both sides. I get 21a equals 42. I divide both sides by 21 so that I get a equals what? A equals 2. Good. I know that this is a lot of work to do. That's why we build from the beginning just multiplying a single monomial times a polynomial. And then we work on simplifying expressions. And then finally we get to the equations with polynomials on both sides. Again, start easy, then work to the difficult stuff when you're practicing, okay? Thanks for watching.